All right, continuing the video here on comparing two means. Pause me here and read example A and example B. One of the things you're going to have to do as you see more and more problem types is make decisions about which tool in the toolbox to pull out. And in this case, you have to decide if the following situations require inference for one mean or two means. And if it's one mean, is it about a single mean or is it about paired data? Or is it about two independent means or two independent samples? So give these a read and decide, is this a question about analysis of a single mean? Is it about paired data? Or is it about analysis of two means from two samples? Pause me and read and decide. Okay, so in A, what was your answer? Here's what we need to look for here. In this particular example, we gathered 20 readings from 20 beakers. We make measurements from each of those beakers. And we're comparing to one single known concentration that we had before. So the question is, how many samples were taken here? That's a place to start. And hopefully you see that we took one sample of 20 readings. There's no pairing going on of any kind. So because one sample was taken, this is a single sample, and the sample means compared with that known concentration. So our test here would be a one sample, probably t-test for means. Now in B, it's a little bit different. We had 20 beakers, but we split them in two. And we did 10 readings in one set of 10, and 10 readings in another set. There's no matching going on. I haven't tied one beaker to another beaker in the other set. I simply have two different methods, treatments in another example maybe, but I have two different methods here with 10 readings out of each. I have two samples of 10 readings each. There's no pairing going on, so this would be a two sample test. So the mean concentration in 10 beakers under one method is compared to the mean in the other. So this would be a two sample t-test for means. And again, you're going to have to make that decision every time you read a problem like this. Now, I talked about the test statistic in the earlier video. Let me just flash back to that real quick. So there's the test statistic T for a significance test. And we could, your calculator will do this, we could use that T to find a p-value for that test statistic and make reject, fail to reject decisions off that p-value. So that's for a significance test. If I'm going to do a confidence interval, let's think about this. I'm interested in an estimate of the difference in averages for two readings I take. For example, in that last example we might look at, perhaps I'm interested in estimating the difference in the reading I took from the beakers under the old method and the new method. So every confidence interval works the same. There's an estimate. Here I have the estimate of the difference, plus or minus a critical value, which is a certain number of standard deviations, right? In this case, the standard deviation of the statistic represented by the difference of averages here. So I have an estimate plus or minus t star times a standard error using S. How do you find t? Inverse t, 1 plus c over 2, but recall what I said in the earlier video, you need degrees of freedom. Again, here's an example where you could use the lesser of sample size 1 minus 1 or sample size 2 minus 1. But if you just let the calculator do this work using a two sample t interval, your calculator will tell you what the degrees of freedom are using the more sophisticated calculation. And if that's the route you go, you need to write the degrees of freedom down. You need to do that in either case. But just leave t star as t star. You could go back and inverse t to find it, but it's not mandatory. Your calculator is determining t star using this fancy degrees of freedom calculation that I showed you earlier. So hopefully that's clear. Lastly here, just point out again, here's your formula sheet, part of it, the back, actually the end of it, depending on how it's printed. And again, we have this generic test statistic calculation and this generic confidence interval calculation. And if we're dealing with a difference of means, we need to understand that our statistic is a difference of sample means. In both cases, that's our statistic. Critical value, that's probably t, probably not z. And then we have this standard deviation of the statistic, which is shown to you here, using sigma. So you need to know that if we don't have sigma, it's t, a t interval, and we're going to pull out sigma and put in s. We're really not going to use this. This is related to the pooled example that I referenced in the earlier video. In the next the next section in chapter 13, this will be the calculation we use for standard error, standard deviation when dealing with proportions. So we'll deal with that in 13 too. So that's complete overview without examples. So given some setup here to the test statistic and the confidence interval for significance tests and confidence interval calculations. There are 2 multi-part examples in the examples video. You should definitely watch those and see the work conducted.